Today we start the lecture number 6, first part of lecture number 6. Uh, this we build a basic model for you, and then we improve it and enhance it to show you some of the modeling technique. In homework number 1, we asked you to forward your entity using a link weight, and now we're using show you how to using a more effective method to forward the entity from one station to another station. Let's start looking at this. The example 6.1, and it's on K-State Online. You can download the model, and also the slide is also available online. And here we have a 3 workstation, as a pen shop consists of 3 workstation, part into the system one by one at the time, follow exponential distribution with a mean of 28 minutes per part. And processing time for the 3 workstation is basically there's a workstation, pen station. After it's pen, it got packing, and these are the processing time given for each workstation. The next slide shows the entity transfer. So they are transferred from unconstrained, do not need vehicle or any other resources, and transfer time from the staging, which is receiving docks, to the first workstation, and from the packing to the exit station required 3 minutes, average 3 minutes, follow exponential distribution. Also, from the first workstation to the pen station, or from the pen station to the packing station, their transfer time follow exponential distribution with a mean of 2 minutes. Okay. And the example I want to study is the utilization of each workstation, how much work in progress we have, and what is the part flow time, basically how much time the parts spend in a system. So let's look at the illustration of the process first. And for the model, we have a staging station, move the part come into the staging and go to the workstation first, and the workstation go to the pen station goes to the pack station go to the exit, and the transfer time was illustrated right here. Okay, so how we're going to illustrate this model, and we're using a arena. Using Simul. Let's take a look how this is going to start. So Simul is right here. Let's bring on this blank Simul station. So here we putting on a source, a sink, and the source we're going to call this staging. Okay, and the sink we'll call it exit. Okay. And then we have a 3 workstation, basically. We have one workstation called workstation. So I'm going to put a server right here and call workstation. And then I'm going to put a server and another server right here. And the server is called pen station. And this server is called pack station. Okay, I'm going to link all these. The parts coming out of staging is going to, so I'm going, instead of using a path, now I'm using a time path. Okay, I'm going to make it prettier later on. So just now I'm going to connect them. Okay, I'm going to zoom up a little bit just so we can organize them a little bit better. Okay. So they look slightly organized. All right. staging first, and trying to move it up to the inter-arrival time is 28 minutes, and we want to make sure it's 8 minutes, okay? And then follow the presentation, and okay, 28 minutes, okay? Processing time is uniform between 21 to 25 minutes. So here I'm going to start changing that. Doing a random uniform and between 21 to 25 minutes. Okay. Second, the pen station is 20. The normal distribution was a mean of 22 minutes and standard deviation of 4 minutes. So this one I'm going to change that also. Start typing random normal. Okay. And now it's 22 minutes average, 4 minutes standard deviation. Also, again, go back to the packing station, triangular distribution, minimum possible time 20 minutes, maximum possible time 26, most likely 22. So I'm going to make a copy of that. It goes to the packing station and change to the triangular distribution, and just copy the one I have over there. And also this is a time path. So these two paths, path 1 and path 2, actually travel time is 3 minutes and follow exponential. So I'm going to say random exponential 3 minutes. Okay. And these two transfer time, actually path 2 and path 3 is exponential. Process transfer time is 2 minutes on the average. So, all right. So this is done. I'm going to kind of organize this a little bit. And I'm going to put in a model entity. We call this parts. Okay, this parts is going to come in from the staging area, go to workstation, goes to pen, goes to packing. So now we already have it, and let's see if we have any information. Okay, we want to run it for 1 day, 24 hours period. So from the September 8 to September 9, this is what we're going to do. Okay, why don't we do this today and to September 4th, okay? We're going to, all we can say is running 24 hours anytime. It's better to do it this way. Okay, let's run. See how they work. Changing the running factor 4 times faster. Probably not enough. Okay, you see this is first section of this thing. So everything goes by the process and just keep coming, and we will show you how to. And after we run it for 24 hours, we can see that actually the server for each one of the pack, painting, or workstation, they have their utilization. For example, workstation utilization is about 68–69%. The pen station utilization is about 64%, 65%, and pack stations utilization will be around 66%. Also, we can see that the flow time actually needed for each one of the parts average about 1.5 hours and maximum is about 2 hours, so on and so forth. So we get those information we want directly from this result. So the next question is how we're going to improve it. So we're going to look at the next lecture video to see how we the 6.2 example enhance this example. This is it.